Hello, my name is Jung Shim. I'm a master's student specializing in the domain of artificial intelligence. I am currently pursuing my research at the PRML lab. Today, I will present to you my project proposal, which I believe is significant in implications for the field of image processing and machine learning and explainable AI in general. Our presentation's table of contents is as follows. First, the project title and its significance. Second is the introduction to my project. Third is dataset description, where I will explain datasets. And four is my baseline model overview. Okay, let's dive right in. First is my project title. My project is titled Image Poisoning Using Color Change. The term image poisoning might not sound so good, but in the context of machine learning, it signifies an adversarial attack on an image, thereby causing models to produce unintended outputs. These types of attacks can be analogous to a Trojan horse, manipulating the model from the inside. If you're familiar with adversarial attacks in machine learning, you might recall several instances where slight perturbations in an image can cause a model to misclassify it. For instance, an image of a cat, when attacked, might be classified as a completely unrelated object by the model. And as you can see in the image below, the panda is manipulated into giving a unrelated 99% confidence output. Yeah. However, many of these attacks have a significant limitation. They are post hoc. This means the attacker has to have knowledge about the model they're trying to deceive. The limitation sparked a question in my mind where if we could craft attacks without this knowledge, not knowing the model. Considering that machine learning models, especially image classifiers, heavily rely on pixel values of the image, I hypothesized that by altering the color or RGB values of the image, we might affect the model's prediction capability. And thus, the idea for image poisoning using color change was born. So, what's our primary objective? We aim to subtly and stealthily alter images so that object detection models produce incorrect predictions merely by tweaking their RGB values. But why is this important? Two main motivations drive this research. A, as AI models, especially object detection ones, become more prevalent in applications ranging from security to healthcare, and it's imperative that we trust their predictions. By understanding vulnerabilities, we can build more robust systems. And B, unlike many adversarial attacks which require knowledge of the model architecture and weights, our proposed method can be applied even before the model is known. This preemptive approach is a significant departure from traditional methods. Moreover, by uncovering these novel poisoning methods, we're not just highlighting vulnerabilities. We are paving the way for future research aimed at strengthening the defenses of machine learning models. Next is the dataset description. For our preliminary experiments, we've chosen the CIFAR-10 dataset, a staple in the computer vision research community. Here's a quick overview. It contains 60,000 images, each of size 32 by 32 pixels and in full color. These images are spread across 10 distinct classes with 6,000 images per class. For training and validation purposes, the dataset is split into 50,000 training images and 10,000 test images. One noteworthy feature of CIFAR-10 is that its classes are mutually exclusive, ensuring that there's no overlap or ambiguity in classifications. As you can see in the right-hand side of the slide, this picture shows that airplanes, automobiles, birds, cats, deer, dog, frog, horse, ship, and trucks are really not hard to classify. So data set wise, I think this is a very good data set, and it is quite doing its job. Moving on to the technical details, our baseline model for this project is a straightforward yet effective convolutional neural network, CNN. Yeah, here's a snapshot. It consists of two convolutional layers designed to extract relevant features from the images. This is followed by a pooling layer to reduce dimensions and capture the most essential information. Finally, two fully connected layers help into the classification task. For training this model, we use the cross-entropy loss, which is standard for classification tasks. The Atom optimizer, known for its efficiency and speed, is our choice, and we set its learning rate at 0.001, which is 0.1%. After training our model for 10 epochs, we then introduce our adversarial attack by adding random noise to the RGB values of test images. The effectiveness of our attack is then gauged by seeing how often our poisoned images fool the model. A quick note to the okay, so more technical details. This is on my environment setup. A quick note on the technical environment is that our preliminary experiments were conducted using a Conda environment on macOS. We've ensured compatibility with Python 3.9 and have leveraged the Torch and Torch Vision libraries for our deep learning tasks. But I'm sure that Python 3.8 and 3.10, 3.11 will all work the same, and I recommend using a Conda environment. This setup ensures reproducibility and ease of deployment. If it is hard to reproduce, I am open to making a Docker file for you, and yeah. And lastly, we have contact information, and first is my email, and second is my mobile. You can contact me on anyone, and so if I were to conclude this, through this research, we're not just trying to find ways to deceive models, we're trying to understand the depths of their vulnerabilities with the ultimate aim of making them more secure, reliable, and trustworthy. And this could be a vision task to someone, but in my opinion, this is more of an explainable AI stuff, XAI stuff, and I wish people who have interest in it will try it out. Thank you for your time and attention, and I'm open to any questions or feedback. Thank you. And lastly, I forgot to share my GitHub repository. Yes, so my GitHub repository is as follows. You can publicly see it, so contact me if you have any other questions. Thank you.